Lesson 52 is on solving systems using inverse matrices. So this is another kind of review topic from Algebra 2, but of course there's one more thing that we're going to learn for pre-calc, right, which involves the Gaussian elimination. This is why we took an extra day to practice it before this. So it says there are many ways to solve systems of equations with matrices. So if you remember in Algebra 2, you solve systems using inverse matrices. So every system of equations that we have, so every set of like 3 equations with x, y, and z, has a matrix equation associated with it. Do you guys remember? So you write it as A, x equals B. Okay, and A is what we call our coefficient matrix. So A, on our example, is 1, -1, 1, 2, 1, -3, 3, -2, 0, because it's the coefficients of our system of equations. 1x minus 1y, blah, blah, blah. X is our variable matrix, so it's x, y, z, and B is our constant matrix. So do you guys see those numbers? 0, 7, -4? They're on the end. Do you guys all remember that? So it's starting it out by just saying verify that these are true. So if I set it up as A times X, and don't be annoyed that I did like parentheses instead of brackets. You can go back and forth between parentheses and brackets, so it doesn't matter. They're the same thing with matrices, like that. So as we know, the first matrix is a 3 by 3. There are 3 rows and 3 columns. The next one is a 3 by 1, and we end up with a 3 by 1. So as we multiply matrices, we multiply rows of the first, columns in the second. We know that we would end up with a 3 by 1 matrix. So if I'm writing this out, take your fingers, right? Remember doing the rub the belly, pat the head thing. So you're going, left hand goes to the right hand goes down. So we're going this way and then this way. So as I do that, I have 1 times x, and then I move both fingers. So I have -1 times y, move both fingers, 1 times z. And that would go in the first spot of a 3 by 1 matrix. Okay. Row 2 would be 2 times x plus 1 times y minus 3 times z, and that would go in the second spot. And the last one would be 3 times x minus 2 times y plus 0 times z. All of that should equal the 0, 7, -4. Do you see where this matrix equation setup comes from? Do you guys understand? The first one is just the first equation, 1x minus 1y plus 1z. That matches up with the spot 0. Okay, do you all see that? That's why we do this. This is why we use matrices to set up the equation. Okay, so basically if I'm trying to solve for x, what I'm going to do is I'm going to divide by a. Okay, but we don't have division with matrices. Do you guys remember that? So what we do is we use a inverse. Okay, so I'm going to show you how to do it on your calculator first. I think you guys already probably remember how to do this. So I'm going to do second matrix. And we will put in matrix A, oops, second matrix, edit. Matrix A is a 3 by 3 matrix. Okay, do you need my calculator up there? Grab it. Yeah. All right, so I'm going to put 1, enter, -1, enter. Man, can't do a minus on my screen. -1, enter, 1, enter, 2, enter, 1, enter. -3, enter. So you're just putting all these numbers in. So I put A in. And then we can put B in. And B is a 3 by 1. All right, and so we get 0, 7, -4. So we go back to our main screen, second clip. So do we have A and B in? So if you want to find this, what we can do is A inverse times B. So second matrix, A inverse. And if I just wanted to find A inverse, I'd just hit enter. So I could do that. A inverse is this. You can go to Math 1 if you want to and change it all to fractions. That's what A inverse should look like. So you just do the x to the -1 button. So you hit your second matrix names A, and then you do x to the -1 on your main screen. All right, but if I wanted to do it all together, I would do A inverse. So A and then raise to the negative 1 times b. So second matrix number 2, b. So see how I have A inverse times b? I just do it all together. And it's saying that those are my solutions. I would do math 1 to get them probably as fractions. So 11 over 2, 41 over 4, and 19 over 4. So that's what x, y, and z are. So for this part, I was just verifying. You don't have to do this. So if I put it all into my calculator, I put in A, I put in B, and I ended up getting x equals, what were the answers? 11 over 2, 41 over 4, and 19 over 4. 19 over 4, was that the last one? All right. Yeah. Did you guys get those?
Yeah, I got it.
Yeah, good. All right, so you guys all know how to use the calculator, right? So obviously we're not going to use the calculator all the time. I'm putting you through this torture. It's better to see it now than see it in college, and you like see it once a week, and then all of a sudden there's like you see it one time and there's a test, final exam on it, right? All right, so invertible matrix. So an n by n matrix A is called invertible, or you can use the word non-singular, if there exists an n by n matrix B such that A times B gives you the identity, but also B times A gives you the identity. Kind of like, like 2 times 1/2 gives you 1, but 1/2 times 2 also gives you 1. All right, so matrix B is called the inverse of A, and it's written as A inverse. Okay, so we kind of reviewed this a little bit yesterday. The inverse of a matrix, do you guys remember the formula? 1 over the determinant of A. Remember, determinant is downwards minus upwards. Diagonal. And then we switch and we negate. So we switch our A and our D, so we get D and we get A. And we negate the other two, so negative C and negative B. So we switch this diagonal. And we negate, meaning we make the opposite, the other diagonal. So we're switching and negating. Oops. Negate. All right, so it says use an inverse matrix and no calculator to solve. So can we do this without a calculator? So a 2 by 2 should be pretty easy. Ben, you paying attention? So we're going to set it up with our A and our X and our B. So A is going to be 1, -1, 2, and 3. Those are the coefficients of the X's and Y's. X is just our two variables, X and Y. We have to put them vertically, otherwise it wouldn't work. And then B is going to be our coefficients, or our constants, 1 and 7. So you can verify A times X does equal B. It gives you those two equations again. So if I want to solve for X, I have to get rid of the A. It's like dividing it over, but what we do instead is we multiply by the inverse. And if I multiply it by the inverse in front, I multiply by the inverse in front here. It's really the only way that you can actually multiply, like using your dimensions. So we need A inverse times B. So first we need to find A inverse. So A inverse is going to equal 1 over the determinant of A. What's my determinant? 3 minus a -2. It ends up being 1/5, right? Well, the determinant is 5, so 1 over 5. And we switch and negate. So when I switch, I get 3 and 1, and I negate, I get -2 and +1. So I have a 1/5, and I'm going to multiply it into every single thing. So I'll have 3/5, 1/5, -2/5, and 1/5. If you are scared of fractions, as some of you just admitted that you are, you can leave the 1/5 out front until the very end. So we're finding this A inverse, which is 3/5, 1/5, -2/5, 1/5, and we're going to multiply by B, 1/7. When we do that, our dimension, this was a 2 by 2, and this was a 2 by 1, right? We're going to get a 2 by 1. Remember, you circle those inner numbers. If they're the same, then you use the outer numbers. All right, so as we do this, rows in the first, column in the second. Can you do this? 3/5 times 1? 3/5 plus, close. 1/5 times 7? 7/5. All right, the next one is going to be -2/5 times 1, -2/5. plus 7/5. So we end up getting 10 over 5, which is 2, 5 over 5, which is 1. Do you think I'm always going to make them that nice?
Yes.
Probably not. No longer algebra 2. But x is 2 and y is 1. All right, number 2. So here's where it gets hard. I'll probably only have one of these on the test if I put it on the test. Okay. Find the inverse of matrix A by hand, and then verify your result with a graphing calculator. So I'm not actually even solving this. I'm just finding the inverse right now. So A would be 1, negative 1, 1, 3, 2, 0, 1, negative 2, 2. If you want to find the inverse of it, you have to adjoin, meaning attach, the identity matrix. You put 1, 0, 0, 0, 1, 0, 0, 0, 1. So we are adjoining the identity. And then we do our Gaussian elimination, your favorite. Thought it was going to go away, didn't you? Sadly. I know. It's rough. I understand. Remember, I told you I took a whole class on this in college. Linear algebra. Matrices every single day for a whole semester. Fun, fun, fun. All right. So it really wasn't that hard, though. It's not necessarily hard. It's just time consuming. All right. So if I want to get that to be a 0, right? I already have the 1. Isn't that good? 1. Yay. So if I want to get that 3 to be a 0, what do I multiply row 1 by? Yeah, so row 1 times negative 3. So negative 3 row 1 added to row 2. All right, row 1's going to stay the same. Negative 1, or 1, negative 1, 1, 1, 0, 0. So we're going to have negative 3 times row 1. So if you guys need to write it out, you can. It's a lot of scrap paper if you do, but that's fine. So negative 3, 0, 0. You're adding it to row 2, which was 3, 2, 0, 0, 1, 0. So your result is 0, 5, negative 3, 1, 0. How about the next row? If I want to get this 1 to go away, what do I multiply row 1 by? Negative 1. Negative 1 times row 1 plus row 2. In other words, row 2 minus row 1. Oh, row 3. Thank you. Who corrected me? Julia? Was that Julia? I heard someone say row 3. You and Julia's voice sound very similar. Let me. All right. Who was that? I don't know. All right. So I'm going to take row 3, and I'm basically subtracting out row 1, right? Negative 1 times row 1 plus row 3 means row 3 minus row 1. So I'm going to get a 0. I'm going to get a negative 1, a 1, a negative 1, 0, and a 1. Did you guys get those?
Oh, yeah.
Just take your row 3 and subtract out row 1. All right. Now what? So you can divide the middle by 5. Is there something that would be easier? Look at that third row. Let's use that third row to our advantage. Notice how it's almost a 1. It's a negative 1, right? So we're going to multiply this row by negative 1, and we're going to move it.
We're going to do what?
So we're multiplying this row right here by a negative 1, and we're going to move it to row 2. So we're going to switch those 2 rows around, which is totally fine. It's just moving 2 equations around, right? So when I do that, I have 1, negative 1, 1, 1, 0, 0, and I'm going to have 0, and then positive 1, negative 1, positive 1, 0, negative 1. And then that third row will be 0, 5, negative 3, negative 3, 1, 0. Okay? So we have the 1 and where we want it. So we have our 1, 0, 0 that we started with. We have a 1 in the middle. Now we get this one to be a 0 and this one to be a 0, right? All right, so how do I use row 2 to get a 0 in the blue spot? Yeah, you just add them together, right? So you're going to take row 2 and you're going to add it to row 1. Now, as long as you're doing it in this order, we talked about this yesterday, Tyler. We talked about this yesterday. You go in a certain order, right? As long as you go in that certain order, you're not messing up anything you've done along the way. So really, like you could write, like you could put in all those different numbers already. Okay? So anyway, so I have row 2 plus row 1. So I'm going to add those first two rows together. So I get 1, 0, 0. Oh, so lucky. 2, 0, negative 1. Second row's the same. We need to change the third row. So how do I change the third row using the second row? Negative 5 times row 2 plus row 3. Did you guys see that? This is one where you might need to write out the numbers. Totally fine. So negative 5 times row 2 would be 0, negative 5, 5. And then we'd have negative 5, 0, 5. And we're adding it to row 3, which is 0, 5, negative 3, negative 3, 1, 0. So our result is going to be 0, 0, 2, negative 8, 1, 5. Still good? Next step. So we got the 1, 0, 0. We got the 1, 0, 0. Next step is to get this to be a 1, right? So if we get that to be a 1, very easy. I just divide that whole row by 2. Bothering me, I don't have my little 1. All right, so we divide by 2.
Oh my God.
So we have 1, 0, 0, 2, 0, negative 1, 0, 1, negative 1, 1, 0, negative 1. And we have 0, 0, 1, negative 4, 1/2, 5 over 2. For inverses, you will often get fractions kind of toward the end of them. All right, so one last step. We're going to try to get this spot right here to be a 0, which is super simple because we're just taking row 3 and you're adding it to row 2. Did you guys all see that? So row 3 plus row 2. So otherwise, the whole matrix is the same. That's okay. I would be annoyed if my husband didn't answer the phone at this point because, you know, every time I call him and he doesn't answer, I'm like, what if I had the baby? Like, I could be having the baby right now.
What if he's
But
he's having the baby.
yeah, he's calling and telling me he's having a baby. I do like lately he's been like, my back hurts. I'm like, sorry about that. Yeah. Anyway, so 5 over 2 minus 2 over 2 is 3, negative 3 over 2. No, positive 3 over 2.
Yeah.
All right. Are we good? Did you guys get those?
Okay, so
All right. So now what we just did, what is this matrix over here on the left? This is the identity. That's what we want. Once you get that this is the identity, then this right here is A inverse. Okay, so we just found A inverse by hand. Now let's verify with our calculator, because you should always do this on your homework, right? If you're like, man, I'm getting some weird answers. Nah, I just said find the inverse. I didn't say actually find the.
Oh, okay. Cool.
It's really not that bad to do that last step and multiply by 7, the 7, 4, 12, but that's fine. We'll skip it. All right, so if I'm putting this into my calculator, so I'm going to put A in.
Well, isn't it
Oops.
1 over the determinant of A?
Nope, it's not a formula for this one. It's using Gaussian elimination. The 2 by 2 has a formula.
I mean, like if we were to try and figure out what X, Y, and Z were.
Nope. I'll show you how to do that. Julia's just made it, so I'm going to do an extra step. Man. All right, so we get 1, negative 2, and then 2. All right, so that's matrix A, right? So if I do A, so second matrix A, and then I do inverse, and I hit math 1, I would always do math 1 if there's decimals. I make them fractions because remember, I love fractions. Don't you guys? Makes things so much easier. Do we get it right? 2, 0, negative 1, negative 3, 1/2, 3 over 2, negative 4, 1/2, 5 over 2. So you can check. Okay, does that make sense? Now if you're going a step further and you're finding the answer, then you would multiply A inverse times B, which would not be that hard. You wouldn't take that whole big thing. You would just take the A inverse part. So 2, 0, negative 1, negative 3, 1/2, 3 over 2, negative 4, 1/2, 5 over 2. And you would multiply by B. And what was B? Like 7, 4, 12? So this was a 3 by 3, and this is a 3 by 1. Doesn't it make sense that we would get a 3 by 1? Because they're going to be X, Y, and Z. So you would do that. And it's not that bad. Okay, so if you have 2 times 7, you get 14, plus 0, minus 12. So what is X? 2, yeah. All right, if I take negative 3 times 7, I get negative 21. I move, I do plus 2. Plus, what's 3 over 2 times 12? 36 over 2, which is 18. So I get negative 21 plus 20, negative 1. And if I do the last one, I get negative 4 times 7 is negative 28, plus 2. And then I have 5 over 2 times 12. Can you guys do that? 5 over 2 times 12. You guys freak out when there's fractions. You're in pre-calc. You're a senior in high school.
30. That's why.
All right, 60 over 2 is
30.
30.
31.
So we get 32 minus 28 is 4.
4.
That's your Z. Okay, so you just go one step further. But finding the inverse is definitely the hardest part. All right, and then these, this one I'll let you go ahead and do it by the calculator. So find the inverse using the calculator. You just have to make sure that you set up your A. So on your test, I would want to see what A is equal to, because you know people use the calculator, but this is the part they mess up on. They forget that 0. They put 1, 1, 0. Right? That's a 0x plus 1y plus 1z, so 0, 1, 1. So I would want to see what A and B are. So put these in as your calculator. And then tell me what X, Y, and Z are equal to. You guys are probably faster than I am. This takes a while on the... So if you get it, let me know. This is the easiest question ever. You guys better be trying it. You're using your calculator for it, so we're putting A in. We do second quit, we get out of there, and then we go into second matrix, we put in B, so edit B. B is a 3 by 1. Shh, guys, there's a lot of talking. So we put in 2, 1, 3. And then we do A inverse times B. So you're going to do second matrix A, inverse, second matrix B, and we end up getting 5, 21, 20, negative 20. Did you guys get those? All right. So 5, 21, negative 20. All right. So I decided to go with something a little bit different for your homework, so let me write it on the board real quick.